Welcome, quantitative literacy students. We're going to take a look at this fixer-upper exercise, and we're going to play around with some formulas and scale drawings to analyze a couple of problems that a homeowner might face when they're doing certain things to their property or house. So let's take a look here. We have the Mazurskis are going to do some work on their yard. And so we need to just take a look and consider what this scale drawing means, and then what formulas we might need to analyze it. So first, let's start off by taking a look at the scale here at the bottom. So it mentions 20 feet is the distance from here to here and 30 from there to there. So what I get out of that is the distance from here to here would be 10 feet. Now, if that's the case, this square right here is 10 feet by 10 feet in each direction. So think about area for a moment. And basic area of a rectangle is length times width. So we have to take that length of 10 feet and multiply it by the width of 10 feet. Oops. 10 times 10 is 100. Foot times foot gives me square feet, or feet squared. We'll abbreviate square feet as SQFT, square feet. So each one of these squares has an area of 100 square feet. So if we count squares, we got to keep that in mind. So what we want to do is estimate the size of the lot, estimate the size of the house, and then we'll actually calculate them. So let's start off with the house. That's relatively easy. If I were to measure the width of the house looking at the front, it's 10, 20, 30, 40. It's 50 feet across that way. If I were to estimate the width coming along this side, I get 10, 20, 30, 40, 50. So 50 times 50, well, 5 times 5 is 25. Add those two zeros onto the end. That's going to give us 2,500 square feet. Now, that's a little more because we're counting in these squares, which actually aren't part of the house there. So as far as just looking at the house, an overestimate of the area is 2,500, oops, missed that zero, square feet. An underestimate would be to look at this side over here and say that's 10, oops, I want to switch color, there we go, 10, 20, 30, 40 feet that direction. So an underestimate for the area of the house would be 40 times 50. 4 times 5 is 20, throw the two zeros on the end, so 2,000 square feet. So I'm going to jump this into my spreadsheet to do the calculation, because my spreadsheet is a calculator. And I think what I'll do for this house is I'll view it as this rectangle right here plus this little pop out right there. All right. So somewhere I have a spreadsheet. There we go. So first thing, I just want to get a sense of the scale. 1 unit on the drawing is 10 feet in reality. And so as far as that scale, 1 square on the drawing is 100 feet squared, or square feet. So that's going to be good to know as we work through this. And then as far as just the house is concerned, I'm going to say it has a length of 50 feet. And again, when I work with a spreadsheet, I not only write down the numbers, but what they mean. Okay, and so here I have what I'm describing, and then I'm going to put the units next to it. And I don't want to put the units with the 50 because I want to be able to multiply by the 50. And typing 50 and feet in the same cell is going to screw things up. I'm going to say the width for this, for now, is 40 feet. And then I'm going to make a note that there's a pop out. I could type or spell, and I'm just going to note the area of the pop-out. So the pop-out, if we look back at the picture, has 2 squares in it, and each square is 100 square feet. So I'm just going to make a note that the pop-out is 200 feet squared, 200 square feet. So calculating the total area for the house, well, basically, it's a rectangle, and rectangular area is take the length and multiply by, so the asterisk on the keyboard, by the width. And so I can just click on each of those numbers. But that misses the pop-out, so then I want to plus add in that pop-out. So the actual area of the house is about 2,200 square feet. And I say about because who knows how exact this drawing is. Okay. We're going to do the same thing for the lot in just a second. Let me make this pretty a little bit. Let's let that span across some cells and center it and colorize it. Nice. All right. Let's take a look at the lot next. So we want to look at the picture and estimate the size of the lot. So I'm going to get another copy of this in a new picture. All right. So what do we got here? So here, again, remind ourselves, distance from here to here is 10 feet. And one particular square has an area of 100 feet squared, or square feet. So the entire lot, I'm just going to count across. I think I'll start in this corner right here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3.5. So remember, each one of those is 10. So here, that's really 50, 100, 150, 200, 210, 220, 230, and a half of one must be 235. So I'm pretty sure the width of this lot is 235 feet. Counting up the other way, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's 11.5 times 10 is going to give me a width over here of 115 feet. So those are dimensions of the lot. If I multiply those two together, that'll give me the area of the lot. So the lot area is going to be that 235 feet times the 115 feet. So I'll have my spreadsheet calculate those numbers. Whip out your calculator if you're watching. So for the lot, we have a length of 235. And make a note of the dimensions because we have feet and square feet. We want to always know which is which. Don't want to mix those up. And a width of 115. And so the area is pretty straightforward on this one. It's just length times width. So we click equals, then click on the length times the asterisk, click on the width, hit enter. So we get 27,000 roughly feet squared or square feet. All right, so let's see where we are on our worksheet here. So backing up a little, we wanted to interpret what does the scale in the drawing mean? So we talked about that. We want to write an estimate of the lots, and we want the area and the perimeter. So I didn't do the perimeter yet. We can look at that. Estimate the number of square feet of the house. We did that. Assume it's one floor. Didn't even think about that, but we did. All right, so let's look at perimeter. What is perimeter? So perimeter, if you remember, is the distance around something. Well, look here. People ask, what is the formula for perimeter? There's a few different ways to think about it, and they're not showing it to me there. So for a rectangle, like over here, this one is 3 by 8. We just want to add our way around. So here they're saying there's an 8 there and an 8 there, a 3 on one side and a 3 on the other. Okay. Another way to think about it is twice the length times twice the width, which they illustrate down here. So there's a couple versions of calculating perimeter. I'm going to go for this version right here. So the perimeter equals 2 times the length plus 2 times the width. So we'll do that in a couple of different ways on our spreadsheet. So perimeter equals, so it's a formula, so I have to start out with equals. In one version, the formula said for a rectangle, which the lot is, take 2 times the length plus 2 times the width. Enter. Now here, we're just adding up a bunch of lengths, so that's just in feet. If they were going to put a fence around the whole thing completely, they'd need 700 feet of fence. Double check that perimeter. I start on the bottom, I have 235 feet. Then I go up, say, the right side, that's 115. Then I go across the top, that's another 235. And then I go down the left side, and that's another 115. So you can see here I have 2 widths and 2 lengths. So it should give me the exact same number. So there's often more than one way to do a job. All right, let's pretty that up and move on to the next part. Next part, we're just going to explore the backyard. So merge those cells, center them, and make them a little prettier. So for the backyard, they want to reseed the backyard. And so Jerry came by from Jerry's Green Team and gave them a bid of $600 to fertilize and reseed the backyard. And so here are his rates. So that to pay for the seed, 4 pounds, cover 1,000 square feet at $1.25 per pound. So we're going to have to do some calculations there. How many groups of 1,000 square feet do we have? Fertilizer, it's 50 pounds per 12,000 square feet, and that sells at 50 cents per pound. And then the labor is $45 per hour, and that's for a 4-hour session. And he says right here, it's going to be about a half a day work. So we just want to double check his bid by using his itemized costs in the calculation. So before we can do that, we have to figure out how big the backyard is, because we're just doing the backyard. So let's again get a new page to scribble on. See what we get. So the backyard doesn't quite line up on each side because of that pop out in the house. So I'm just going to break this into 2 parts. I'm going to say I've got this rectangle right here for the backyard. And then we can add in that pop out. So let's highlight that. This pop out right here, each one of these squares represents 100 square feet. So I have 100, 200, 300, 400, 500 plus a half. So the pop out part has 550 square feet of lawn. For the rest of the yard, I can just count across here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's, remember, each one of these is 10, so that's 50, 100, 110, 20, 30. We're 130 feet across that way. And we already calculated that, or counted, we're 115 feet heading up that direction. So my area is going to be, remember, area is length times width. It's going to be these 2 multiplied, but then I got to add in the pop out. So let's throw that in the spreadsheet and see what we get. So backyard has a length. It's got a width, and like the house, there's a pop out. So I'm going to say the length is 130 feet. Remember, type those in different cells because you need to multiply with the 130 or add or whatever. Then we have 115 for the width. It doesn't matter which one you call the length and which one the width. That's okay too. And the pop out, we calculated as 550, and that one was square feet. Okay. So the total area for the yard, total area is going to be regular area is length times width, and we have to add in the extra pop-out area of that backyard. So I'm getting 15,500 square feet. All right, so we know how big the yard is. Next, we need to try and put in there the other things he talked about. So we got grass seed to consider. And the grass seed, let's see, what did it tell us? 4 pounds per 1,000 square feet. So we have to use that. And we're also going to have to use the cost, right? Because ultimately we want cost. So we need to know how many groups of 1,000 square feet are in our backyard. Well, when we're looking for groups of, that's division. So we'll use a division on that. And we'll double check that by just penciling this out. So new page. We want to convert our area into cost. So our area is 15,500 square feet, or feet squared, however you want to write it. And we were just given a ratio that square feet's going to have to go on the bottom. And let's see, I think they told us pounds of grass seed. So every 4 pounds of grass seed will cover 1,000 square feet of lawn. So writing the ratio in this way is going to allow us to get rid of square feet. Now the next ratio they gave us was that it's going to cost $1.25 per pound. So here I can multiply by another fraction to get rid of pounds and change that to dollars, and the rate was $1.25 per pound. And that's going to allow me to get rid of pounds. So according to those conversion numbers given on the worksheet here, I end up with this way of putting them together. So I can convert my area to cost if I multiply by the ratio of 4 pounds per 1,000 square feet, and then multiply by the $1.25 per pound. And notice square feet goes away, pounds go away, that leaves me dollars behind. So I want to take my 1,500, multiply by 4, divide by 1,000, and then multiply by 1.25. So we're going to plug that into our spreadsheet. So how do I want to do that is the question. So grass seed. We've got coverage, I guess. And our coverage is 4 divided by 1,000, and I should type that as an equation, so equals, and that measures pounds per square foot. Oh no, sorry. All right, back to work. Oops, I didn't want that to be in there. Enter, okay. And that is in pounds per square foot. And the other thing we have is the cost, and that is $1.25. And again, that is dollars per pound. And so we just figured out that to get the total cost for the seed, I'm going to take our area, so I equals, take my area, multiply it by my coverage, which multiplies by 4 and divides by 1,000, just like this fraction said to do here, and then multiply by the 125. Okay, so just the grass seed alone is going to cost $77.50. So after grass seed, we have something similar to do for fertilizer. Fertilizer, something like that. So fertilizer also has a coverage, and the coverage is listed as 50 pounds per 12,000 square feet. So here I can just type equals 50 divided by 12,000, and make a note that that is pounds per square foot. And we could probably clean that up a little bit by dropping the decimal places. How about 4 decimal places should be enough to see? Okay, we also have the cost of the fertilizer. And that is 50 cents, or in dollars, 0.50. And that's dollars per pound, according to our information. Similar to above. So we can get the total cost in a similar manner. We're going to go equals our total area of the backyard times the coverage amount, which is our 50 pounds per 12,000 square feet, then times our dollars per pound. And again, we'll look at why that works in just a sec. So it looks like it's going to be only about $32 for fertilizer. So this was for grass seed up there. As far as fertilizer goes, we're still going to start with our same area, right? 15,000 square feet. 15,500, excuse me. And here we're told that for every 12,000 square feet, we need 50 pounds of fertilizer, and that the fertilizer is going to cost us $0.50 for every 1 pound. And so that conversion allows us to get rid of square feet, changes to pounds. Once we know how many pounds, we can convert into dollars. And so the spreadsheet took that ratio times that dollar amount and gave us that 30-something dollars. Okay, we're getting there. Next thing to consider is labor. And as far as labor goes, he just stated in his advertisement that it's 4 hours, it's at $45 per hour. So we'll make a note of that. And he said he could do this in half a day, which I would consider to be 4 hours. Okay, so we have, let's see, hours for rate is $45 per hour. So the total cost there, labor, is going to equal the product, number of hours times the dollars per hour, 180. So final total cost, if we just go by that, his itemized cost should be the sum of those last few things. So the labor cost plus the total cost of the fertilizer plus the total cost of the grass seed. Add those up, I get $290. He bid $600. Whoa, how come his bid is double what his itemized costs say? What else is he charging us for that he didn't tell? Not sure. That's interesting. Okay. And again, that number right there was based on these other ones. So let's bring those in here and highlight them. All right. So we just went through about the first third half of this project. I'm going to make a brief note on the next one, and I'll come back with a different video to finish this off. So is Jerry's estimate consistent with his advertisement? It looks like it's not. And so you need to document on paper or on a spreadsheet or both how you come up with your finding for that, similar to what I just did here. Next part is we want to do a chain link fence. And let's see, just around the backyard, okay? And the fence is going to have 2 gates. And so here are the costs for the fence, for the gates, and for the posts Now we have inline posts and we have corner posts, and they have different prices for each one. So new page, I'm just going to get it started. I'm not going to finish it right now. So first I'm just going to draw where the fence goes. So let's use a blue highlighter for that. The fence, obviously, is going to be all the way across the back. It's going to be all the way up the side here. It's going to go over here, and then we're going to have the gate. Now we don't need a fence up against the house, but we do have another gate here. And then the fence is going to continue along like that. And then I'm going to need corner posts, right? Where are the corner posts going to go? Let's use red dots for that. Well, there's a corner here, and there's a corner here, there's a corner here, and there's a corner here. Now, we're not going to attach gates to to the house. So the question is this going to be an inline post right here, or is it a corner post? Corner posts take a little bit more stress than a regular post, and so gate areas take a little more stress in the middle of a fence. So I'm going to have to, for me, I would say, there's going to have to be a corner post up against the fence there and there. And then where the gate meets, that's really not an inline post, that's an end post or corner post. So those red dots are where all the corner posts are going to go. And then they tell us how often we have to put other ones. So you're going to need an inline post at least every 8 feet, which means you can't have it two inline posts more than 8 feet apart or an inline post more than 8 feet from a corner. So now you're going to have to troubleshoot here to figure out how many inline posts you're going to want going across here. Okay, and so you're going to have to calculate that. And remember, we have a scale here to help us do that. So I'm going to leave you to that, and I'll come back with another video soon, finishing off the rest of the Mazurski's yard. And then we've got one more problem where we're going to add a little patio here, and we're going to throw down some concrete. So we need to calculate how that's going to work. So more on that soon. Take care. Do good math. Bye-bye.